Right, this is with 14.1, Understanding Polynomials. So, a couple vocab terms. Polynomials, they can be, poly itself means many, so it is that it can be made up of many monomials or more than one. So, an example is just a monomial cannot have more than one term, and it cannot have a variable in its denominator. So something like 2x squared is a monomial, but if I had 2x divided by y, that is no longer a monomial. Binomial means that it just has two terms, so something like this 2x squared plus 3x would be a binomial. There's one and two terms. While a trinomial is going to have three. Again, that kind of first part of those roots telling us what we're going to have. So here is an example of a trinomial. It's got three terms in it. So part of that is just identifying monomials. We need these to identify polynomials, but getting there. To identify a monomial, mono means one, so it needs to have one term. So for example, this 2x squared to the y, or times y, this is one term. When we are multiplying them together, that works just fine. This one on the left, however, I have got a term here and here. This is not a monomial. This is actually a binomial. Bi means two. The other classification for a monomial is that the exponent needs to be positive if it has an exponent. So in this case, x minus or x to the negative 3 would not be a monomial. It also needs to make sure that the variable is not in the denominator if there is a denominator. The other classification is that the exponent needs to be a whole number. So in this case, our ones on the left, these are not monomials, while the ones on the right are monomials. They are multiplying each other. This 5 squared can be 5 times 5 or 25, so we can always reduce them. The numbers, the single variables, if they're multiplying, it's got a positive exponent. This is what classifies it as a monomial. This helps us when we get to identifying polynomials. For example, if I were to take a look at these, both of these have two terms. However, the terms need to be monomials. In this one here, that 0.5 in the exponent means that it is not a monomial, therefore this is not a polynomial. However, this one on the right, I've got two different terms, so while it's not a monomial, poly means many. This one technically has two, so I would actually replace that poly with a bi, so binomial. Both of them are multiplying, all the exponents are positive, there's no variables in the denominator. So it crosses all of these, each of these are monomials on its own, which helps us classify the type of polynomial it is, or if it is a polynomial or not. Now, in terms of classifying them, we first identify the term, but then we also need to figure out the degree. So the degree of something is the sum of the exponents. So in this first one, there's technically an exponent 1, so it has a degree of 1. And there is one full term, so it would be a monomial. This second one here, there are two different terms. So this is a binomial because it is made up of those two terms. Looking at my exponents, I just have 2, so it's a degree of 2. When I were to look at something like this one up here, this 4x squared, y cubed, it's a monomial. There's one full term. However, looking at the exponents, I've got 2 and 3. The degree is going to add those two together, so it has a degree of 5. So then again, looking at this bottom one, it's a monomial. There's one single thing, one term. The exponents, this y technically has an exponent of 1. If there is no exponent written, it has an exponent of 1. So I'm going to have 2 plus 1, so it has a degree of 3. So degrees, add the terms, or add exponents. All right. In terms of simplifying polynomials, so this is where we are going to do things like terms. So something I'm going to do, and that we've done in our class, is we've taken our colored pencils and we've highlighted anything that has the same one. So I'm looking in this section for all of the x squareds y to the fourths. I am going to include the numbers in front or the symbols in front to help me identify. So going through these, I've got 5 here, 7 here. This one says positive, so if I add them together, I'm going to have 12 of these x squared y to the fourths. Then I'm going to look at, looks like I've got an x y to the cubed. Looks like I have another one of those here. I've got a negative 4 of them here, positive 2. Add those two together, I'm going to end up with negative 2xy to the third. And looks like I am finally left with this little thing on its own. So the 4xy. So these, look for those light terms, highlight them if you need, box them if you've got them in there. One thing you can do is also cross them out to be like, okay, I've got this simplified, I added those together, I don't need to worry about that anymore. With evaluating polynomials, we've done something similar to this when we have been looking at our systems of equations. This is essentially when we take a number and we're going to plug it in for x to evaluate. So in this case, I have 50 times 6 squared plus 250. Now at this point, remember your orders of operations, PEMDAS. So right now there are no parentheses. I mean, for me, nothing to do inside parentheses, so I'm good there. I do have exponents, so I'm going to do that 6 squared. So that's going to end up being 50 times 36 plus 250. Then I'm going to do the multiplication division. So 50 times 36, and if I type that into my calculator, we're going to get 1,800. There's that part done, and then finally addition, subtraction. Add these two together, we should get 2,050. So when you're evaluating, make sure you plug in the number that they give you or the value in for the variable. Do the exponents first, multiply and divide, then add and subtract going from left to right.